let's look at the general rule. Looking at the general rule, you have a few variables that you need to know what they mean. So the first one is the absolute value of A. The absolute value of A is going to tell you if you have a vertical, stretch, or compression. If the absolute value of A is greater than 1, you're going to have stretch. If it's less than 1, you're going to have compression. If you have a negative in front of the A, negative, that's going to tell you a reflection across the x-axis. H is the number inside of the parentheses, and when you look for H, you always want to do the opposite, so you change the sign, and that's going to tell you horizontal translation. The exponent, which is n, tells you the graph or the parent graph you're dealing with. So if you have an exponent of 2, that's a quadratic, exponent of 3, that's a cubic. So the previous slide showed you the table so you can know the name of the parent function. And the number at the end is k. Do not change the sign. Do not change the sign. And this will tell you a vertical translation. The function can have h and k. It can have h only and no k. It can have k only and no h, and obviously the function can be missing the h and the k. So if you don't have k, the value of k is 0. If you don't have h, the value of h is 0. Now a can also be imaginary 1. If it's imaginary 1, you don't have to mention vertical stretch or compression, only when it's more than 1 or less than 1. If you don't see a negative in front of A, you don't have to mention reflection across the x-axis. You only mention that when you have a negative. So let's try an example. Well, hello guys, this video is for the introduction to parent functions. There's a lot of parent functions out there. We're just going to look at some of them. And with the parent functions, you need to know how to transform each parent function, how to identify the parent function, and how to find domain and range. So looking at the table that you guys have for the parent functions, one thing that you need to understand and know is what the parent function looks like when you graph it. When you have the actual equation or the function, what is the parent function, and if it's transformed, how is it transformed. So looking at this table, we have a linear. Linear is when you have f of x or y equals, and you have an x to the first power. There's an imaginary 1 exponent. The graph is just a line. For the quadratic function, we have f of x and you have an x squared. The graph is a parabola. Cubic function, f of x equals x cubed, so there's the exponent of 3. And the square root function, well, you have a square root and the x inside. And the graph is kind of like a check mark going to the right. All these functions can be transformed, and using h, using k, we know what translation is made, and also we can know the vertical stretch or compression. But you really need to understand what the general rule is to know the type of transformation. One thing that is very important to remember is, notice all the parent functions, they go through the origin, 0, 0, so it crosses the origin. And that's very, very helpful to identify if a function is the parent function. Now, not all the parent functions or not all the functions that crosses the origin is the parent function. We also have to look at different things to identify the parent function. So it says here, identify the parent function of g from its function rule and describe what transformation of the parent function it represents. So there's a couple things we want to do in this problem. First, we want to identify the parent function, and then we want to describe what transformation of the parent function represents. So, first, let's look at the exponent to identify the parent function. So here we have exponent of 3. So that's going to that tells you it's a cubic function. So we already did identify. Now we need to describe the transformation. That's where the negative, the a, the h, and the k comes in. So let's look at the negative first. We do have a negative. Since we have a negative in front of a, this right here tells us it's a reflection across x-axis. The absolute value of a, which is 1/2, absolute value 1/2 is 1/2. In this case, is less than 1. So the absolute value of a is less than 1. So this is going to be vertical compression. The number inside of the parentheses, we do have one, is h. We always do the opposite, so the value of h is going to be +1. If you have a +3, you change it to a -3. But since it's -1 inside of the parentheses, it becomes a +1. So this, it's an horizontal, H for horizontal, translation, T for translation. Now you have to mention how many units, okay? We know it's horizontal, sideways. Since it's +1, you go 1 to the right, 1 unit right. And the last number at the end is k. Now k, do not change the sign, it stays the same. So if you have a -2, it stays as -2, but right now we have a positive, so it stays as +2. This one is vertical translation. V for vertical, T for translation. It is positive, and we know vertical is up and down, so +2 means 2 up. So when they want you guys to describe a transformation, you need to write down what the transformation is. You can have everything like we do here. You can have a reflection, you can have a vertical compression, horizontal translation, and vertical translation. You don't have to have all of them in a function. Some functions might have a reflection across the x-axis and a vertical compression only, or you might have horizontal translation and vertical translation only. Okay, so this is introduction to parent functions and transformations. Make sure you review the general rule and understand the variables.